In this video, I am going to present you about the math module of Python. This math library contains huge amount of functions. We will study one by one. This video covers basic mathematical operations like sum, exponential, modulus, etc. Math module contains constants like pi, Euler, tau, etc. Arithmetic function, cell, floor, etc. Power function like pow, exp, and the logarithmic function. Let's start with Python constants. The module includes several famous mathematical constants and important values like pi, tau, Euler's number, infinity, and NotNumber, which is represented as NaN. Let's start one by one. So first one is the pi. Pi is the ratio of circle's circumference to its diameter. Pi is written as C by D, where C represents circumference, D represents diameter. Its value is 22 by 7, or in decimal fraction it is written as 3.141 approximate. So whenever you are going to use this math library function and constant, you have to import math module. So let me show you how to import this math module and call this pi constant. Now let me open the Python interpreter. Here, let me import math module first. So import is a statement or a command to import Python library. So it will be import math, then give enter. Now if you write math.py, it will show you the value of pi. So this ratio is common to every circle. There is another way to write this import math statement. You can also write like this: import math as m. So whenever you call the math constant or math function, you can just write m.py. So you do not have to write the full module name, that is over here it is math. Give a short name of math. So I have written here m. So wherever I use this m, so that will be represented as math. So you can write like this: import math as m. Let me show you how to calculate the circumference of a circle with radius 5 units. So first of all, let me again import this math module. So it will be math as m. So m is the alias name of math. Give enter. Radius is 5 unit. Now c equal to, c means circumference, equal to, the formula is 2 pi r. Let me write down 2 multiply m dot pi multiply r. Now print circumference equal to c units. Circumference of the circle with radius 5 units. Now it's a very interesting fact that pi is a well-known mathematical constant in the world. It has its own celebration date called Pi Day, which falls on March 14th, 3/14. Next, move to tau. Tau is the ratio of circle's circumference to its radius, that is 2 pi r divided by r, where r is the radius. This constant is equal to 2 pi, or roughly 6.28. Let me call the tau constant from the math module. So import math as m. Just write down m dot tau. So it will give you the value of tau constant. It is 6.28318. Next, Euler number. Euler number is an irrational number with infinite decimal places. The value of e, that is the Euler number, is often approximated as 2.718. Euler numbers is used to calculate the population growth over time or determining rates of radioactive decay, etc. Euler number is a constant that is the base of the natural logarithm. If you have no idea about the mathematics, go and find math video in the YouTube, because I am not going to explain you about the mathematical portion in this video. Now let me access Euler number from the math module. Look, so just write down m dot e. So this is the Euler constant, 2.718. Next constant is infinity. Infinity cannot be expressed by a number. It is a mathematical concept representing something that is never ending. Infinity can go in either direction, positive or negative. Let me show you how it is used in Python. So first import math module. Let me write math or m.inf. So it will give you inf. If I write minus m.inf, so it will give a negative infinity. So the first one is the positive infinity and it is a negative infinity. Obviously, infinity is not a numerical value. Instead, it's defined as math.inf. Python introduced this constant in version 3.5 as an equivalent to float inf. Since I am using 3.6 version of Python, so let me show you. So it will give you the true value. This infinity, m.inf, is greater than any value, any numeric value. So if you write like this, m.inf, whether it is greater than 10 or not, obviously it is greater than 10. You can write any big number in place of 10, but m.inf will always be greater than that number. It will always give you true. Now if you add or subtract any number with this infinity, it will always give you infinity. Let me show you. If you add some numbers, say 456 with this infinity, so it will give you an infinity. If you divide infinity by 123, it will give you inf. So it's clear that neither addition nor division changes the value of math.inf. Come to the next constant, that is the NotNumber, nn. Represent the value is not numeric. Nn value can be due to invalid inputs. It is not really a mathematical constant. There is a function where you can check whether the number is not a number or not by the help of isNaN function. Now if you write m.nn, it will give you nn, not a number. Next, let's move to arithmetic functions. So there are several arithmetic functions. Let me discuss one by one. The first one is the factorial. Factorial of a number by multiplying all whole numbers from the chosen number down to 1. That's mean factorial of 3 means factorial can be expressed as like this or like this. So it will be 3 multiplied 2 multiplied 1. Factorial of 4 is equal to 4 into 3 into 2 into 1. And its value will be 24. So this is how you calculate factorial of any number. It can be done by using the for loop or while loop, which are discussed in later videos. But this factorial can be calculated simply by using this factorial function. Let me show you. Let me call the math module first. Import math as m. Next m.factorial, say 4. So factorial of 4 will be 24. Next, sil. Sil returns the smallest integer value that is bigger than or equal to a number. It means that suppose you want to find the sil of 5.3. Suppose you are sitting in a room and it has a ceiling and the floor. And this 5.3 is lying in between the ceiling and floor. So let me write it like this. So 5.3 is lying in between this ceiling and this floor. Ceiling returns the smallest integer value bigger than or equal to the number. So the bigger integer number greater than 5.3 is 6, and the biggest integer number smaller than 5.3 is 5. That means 5.3 is lying in between these two whole number 5 and 6. So whatever may be in the decimal fraction, the ceiling of 5.3 will be 6 and the floor of 5.3 will be 5. So for 5.3, ceiling of 5.3 will be 6 and floor of 5.3 will be 5. Let me show you by writing it in the Python interpreter. So if you write m dot say CEIL and write down 5.3, so it will give you 6. And if I write m dot floor 5.3, it will give you 5. Next, trunc, TRUNC. This is the short form of truncation, used to eliminate the decimal part of a number with a decimal point. Let me show you by this example. Say m dot TRUNC within bracket, let me write down 2.3895678. Close the bracket, then give enter. So it will just simply eliminate the fractional part or the numbers after the point, and it will give you the integer only. Next is close. It determines whether two numbers are close to each other or not. It has tolerance for closeness. It will return true if the two numbers are within your established tolerance or closeness, and otherwise return false. It may be relative tolerance or absolute tolerance. So I'm not going into the details. Let me show you with an example. But the example that I'm going to show you, this is with respect to relative tolerance. The default tolerance value of relative tolerance is 0.801. So there are 8 0 and a single 1 after this decimal point. First import the map module. Now if I write m.isClose within bracket, suppose 5 and 6, whether they are close to each other or not. No, this will be false. Now if I write the same thing, and let me copy and paste and write down 5, 1 2 3 4 5 6 7 8 9. So there are 9 after this decimal point. So 5.9999999, 6, whether these two are close to each other or not. Yes, these two are very close to with each other. So it will give you a true output. Next, the GCD function. GCD function will find out the GCD among two numbers. GCD means greatest common divisor, or you can say highest common factor, HCF also. So let me show you the HCF between, or the GCD between 20 and 45. So just import the map module, then m.gcd 20, 45, and 5 is the HCF, or you could say the GCD of 20 and 45. The last one is the sqrt function. It will find out the square root of a number. Import math, then write down math.sqrt within bracket, say 25. So this is the square root of 25. You can also use a floating point number, say 30.55. So this is the square root of 30.55. Next, come to the power function. The first one is the pow function. Pow returns the value of x to the power of y. It can be written as, or think as, x to the power y. If a third parameter is present, it returns x to the power of y modulus z. So for the time being, forget about the last line. Think that the pow function returns a value of x to the power of y. So this pow is an inbuilt function. You do not have to use the map function. Again, pow function exists within the map module also. So you can use this function with the help of map module as well as without using map module. So when you are using pow function without using the map module, it is an inbuilt function given by the interpreter. Let me show you one by one. First of all, import the map module. Let me write the alias name of map module as m. Now if I write m dot pow 2, 3, it will give you the value for 2 to the power 3. That is the 8.0. So pow function always return the answer in floating point. Now there is an inbuilt operator double star which represent also the power operator or the exponent operator. If you write like this 2 double star 3, it is also give you 8, but in the integer format. Now if you write 2 double star 3.0, it will give you 8.0. This is what the difference between the pow function and the map module and the given operator double star. So there is another built-in ways to find the power of a number, that is using the pow function without using the math module. Let me show you that. If you write just pow within bracket 2, 3. So this is not under the math module because I have not used any math module or the alias name of math, that is m. So look here, I have not written anything in front of pow functions. So if you write this one and press enter, you will get 8. Now look at the last line. In case of pow function, which is not under the math module, there is a concept of third parameter. So if a third parameter is present, it returns x to the power of y modulus z. So let me show you this as an example. Now if I write pow 2, 3 and then comma 5, so it will give you 3. That means it is similar to 2 to the power 3 modulo 5. So this is what I have said just now. X to the power of y, think that 2 is x and 3 is y and 5 is z. So x to the power y modulo z. So 2 to the power 3 means 8, and when this 8 is again divided by 5, the remainder will be 3. So it will give you 3 as output. So both this statement, pow 2, 3, 5, it is identical with 2 to the power 3 modulo 5. And for that, if you give a double equal to in between these two expression, it will give you true. Next, exp. It calculates the natural exponent of a number with the base set to e, that is the Euler constant. When Euler's number is incorporated into an exponential function, it becomes the natural exponent function, look like this, fx equal to e to the power x. This function is used in real life situations. It can be used in human population growth or rates of radioactive decay. The value of the function grows rapidly as the x value increases. The Python math module provides a function exp that lets you to calculate the natural exponent of a number. So when you use it in the Python programming language, you have to import the math module first, then m.exp within brackets, say, let me write 1. So this is the exponent of 1 and it is 2.718. The given value can be positive or negative. And if the given value is string, it will give you an error. You can write the same thing as m.e to the power 1, where e represents the Euler constant to the power 1. You can also use this pow function and write down m.e, 1, and it will give you the same value. You can use this function in a number of fields, like radioactive decay happens when an unstable atom loses energy by emitting ionizing radiation. So in this video, I'm not going to discuss you about all this physics and maths. Next, come to logarithmic function. Logarithmic function can be expressed the inverse of exponential function. So it is written as fx equal to log x base a. The natural logarithm of a number is its logarithmic to the base of the mathematical constant e, that is the Euler constant. Let me execute this in the Python interpreter. So for the natural logarithm, just write down math or m dot, just simply write down log, nothing else, and then write any value, then give enter. So this is the log of 2 with the base e. But if you write m dot log, say 8, 2, these 2 will be act as the base. So log 8 base 2. So that's mean it will give you 3.0. It will always give you the answer in the float value. Now separate functions are provided for the log base 2 and log base 10. Now if you write m dot log 2 within bracket 8, so it will give you the same value 3.0. So when you are writing log 2, it is considered as log of this 8 with a base 2. Similarly, log 10 is used to calculate the log value to the base 10. Now if I write m dot log 10 within brackets, say 100. So it will be log of 100 to the base 10 and it will give you 2.0. So this will be sufficient for you. More functions are available under this math module. Let me tell you some of them. That is the fsum. It returns some of the values of iterable like array, list, tuple without loop. Suppose you have a list of number. Let me show you an example. Suppose you have a list, say A, and it has 1, 2, 3, 4. So you do not have to use any other Python construct to calculate the sum of this list. If you use this fsum function, you can easily find out the sum of this element within this list. Let me import the math module first. Next, declare a list, say A equal to 1, 2, 3, 4. Now if I write m.fsum and within bracket A. So look, 1 plus 2 plus 3 plus 4, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. So it will give you the sum of all the element within this list, that is 10.0. Next, sine. This sine function will calculate the sine value of an angle. Now if I write m.sine, say 90 degree, so it is giving like 0.893. Sine always give the output in radians, not in the degree. So let me show you how you are going to convert this 90 into the degree. For that you have to write sine 90 and multiply this pi by 180. So multiply m.pi divided by 180 and you will get the value in degree. 90 is considered as radians, so I multiplied this 90 with pi by 180 and I get the value in degrees. M sine 90 degree is equal to 1.0. In the same way, you can use the other trigonometric functions like cos, tan. A sine means arc of sine, arc of cos, and a tan also. You can use radian function to convert degree to radians. Degrees function is used to convert radians to degree. I am not going to show you this radian degrees, try it yourself. Still, if you have any problem, write it down in the comment box. I will reply you back as soon as possible. Let me show you another functions which is commonly used, which is hypot. It calculates hypotenuse of a triangle. Let me show you this hypot in the editor. If you write m.hypot, this is my perpendicular and 4 is my base, and the hypotenuse will be calculated as 5.0. So this is all for this video. There are many more functions under this math module, so the rest will be discussed in a separate video. Thank you.